Welcome to Proving the Point, where we discuss important research papers that you should know about. Today we're going to talk about this paper called "The Parsimonious Neutral Model Suggests Neanderthal Replacement Was Determined by Migration and Random Species Drift." So you should be familiar with Neanderthals, but this is a type of hominid species that existed in Europe and West Asia. And they dominated this area for hundreds of thousands of years. But then within the past 100,000 years or so, they were replaced by modern humans, which were migrating into the region. And so there's a debate about why modern humans were able to outcompete Neanderthals in this area. And what this paper explores is that there was no adaptive superiority to the modern humans. In other words, they weren't better adapted to the area. It might have just been the case that because there were waves of immigration coming into Europe, where the Neanderthals resided, that was enough to basically overwhelm the Neanderthal population and gradually replace them. So the reason this paper matters is because there might be something similar happening in Europe today, which is that there are waves of immigration, both from Africa and from the Middle East and other areas, into European countries. And it could be the case that the native European populations that exist are gradually going to be displaced and replaced by the immigrating populations. Okay. And again, this paper sort of makes that case. They're doing it for a different reason. They're looking at Neanderthals that existed in Europe being replaced by humans coming from Africa. Okay, but the same concept could apply today, which is we have a native European population in Europe potentially being replaced by migrant populations coming from Africa and the Middle East. Okay, so we're going to look at this paper and we're going to think about it in terms of our modern day predicament. Okay, obviously the reason that the migration and replacement migration is a problem is because we don't want to be replaced as European people. Okay, so we have to understand the full consequences of even low levels of immigration, as this paper will talk about. Right, that can have radical changes on a population's demographics. And we don't want to end up like the Neanderthals. So we need to be aware of what's happened in the past so we can stop it from happening again in the future. So before starting this paper, we need to talk about the history of humans and other hominid species. So hominid species were developing in Africa. So this is the conventional understanding by most academics. So take it with a grain of salt. A lot of this information has changed a lot in recent years and will continue to change as they learn more about genetics and things like that. Okay, but the mainstream view holds that hominids were developing in Africa, various hominid species, and then the first wave of hominids leaving Africa happened around 1 to 2 million years ago. Okay, and then it's thought that this population would have gone to colonize areas of Asia and Europe. And then it's thought that around 500,000 years ago, there was another wave of hominids leaving Africa. And these intermixed with and or replaced previous hominids that had left, again, colonizing much of Europe and Asia. And it's thought that this 500,000 years ago out of Africa event is what ultimately gave rise to Neanderthals, which is the subject of this paper. Okay, and there were various other waves. Again, it's thought that there were various other waves of hominids leaving Africa at different times, intermixing with the previous populations that had left. But then it's thought that around between 50 and 100,000 years ago, that's when the main human out of Africa event happened. Okay, the idea is that a relatively small population of anatomically modern humans left Africa around this time. And they would eventually go on and basically outcompete earlier hominid species that existed in Europe and Asia at the time. Okay, so the question is, how did they outcompete and replace these earlier hominid species that existed in Europe and Asia? Well, one model is that they didn't have a selective advantage. They weren't better adapted than their predecessors. The reason they were able to replace them is just because they had higher population numbers eventually, and then there was just waves upon waves of migration that was unidirectional. In other words, Neanderthals really didn't migrate back toward Africa, yet African populations were migrating out into Europe and Asia. Okay, so this unidirectional migration is what's thought to really be important in this paper. Okay, so now we can get into the paper. First of all, they talk about the debate for how Neanderthals were replaced. Again, the question is, was there some environmental pressure imposed on the Neanderthals that made the humans better adapted? Well, maybe. Or, as this paper argues, it's just migration. It's waves of migration that led to Neanderthals' replacement, not necessarily a selective advantage by the humans. Okay, and again, for us, we're really just interested in this paper because of how it applies to us today. And again, their argument here is basically just waves of unidirectional immigration, regardless of whether or not the immigrants are better adapted than the native population, can lead to replacement of the native population. So, as their result, they say, the eventual replacement of Neanderthals was determined by the repeated migration of modern humans from Africa into Eurasia. So again, today native Europeans are akin to the Neanderthals of this study. They are being replaced by the repeated migration of people from Africa into Eurasia. So again, we need to learn the lessons of the past if we're to avoid something similar happening in the near future. Okay, so in this paper, again, they give a bit of a background as to how modern humans are thought to have arisen and where they came from. So we'll read a little bit of the background and then we'll focus on the methods and the results of this paper. But they say modern humans, henceforth moderns, migrated out of Africa, where they had evolved and where their population was large, into the Levant and thence into parts of Eurasia. As migrating bands of moderns expanded the species' range, they encountered small populations of other hominid species, Neanderthals, Denisovans, and perhaps others, that seem to have occupied an ecological niche very similar to their own. So, modern humans are migrating out of Africa and encountering all these other hominid species that have migrated out previously. Okay. It's worth noting that some scholars believe that there were waves upon waves of immigration out of Africa into Europe, consistently replacing the previous population. So one population would move into Europe, then another population would migrate in, and there were just waves of replacement migration happening. So replacement migration, it's not necessarily a new phenomenon. This is not the first time Europe has experienced this. So again, we need to learn the lessons of history. Okay, so back to humans and Neanderthals, it says the two species temporarily coexisted ended in the complete disappearance of the Neanderthals by 38,000 years before present. So again, the Neanderthals went extinct because more and more humans just kept coming in from Africa, and eventually they overwhelmed the Neanderthals and replaced them. Okay, so again, the question is, why did the Neanderthals get replaced? Why weren't they able to outcompete the immigrants who were coming in? Some explanations have highlighted environmental factors such as climate change, epidemics. It says maybe there was direct or indirect competition with modern humans in which modern humans had some selective advantage. I think that's probably what most people envision when they think about Neanderthals being outcompeted by modern humans. It's worth saying that Neanderthals were also thought to be highly intelligent. So it's probably not the case that there was some major intelligence difference between the two populations. And Neanderthals were also very robust physically. Okay, so it's unlikely that the modern humans were somehow physically superior to the Neanderthals. Okay, I've seen other papers talking about how there might have been better social organization among the modern humans, which might have given them an advantage. Okay, but anyway, they don't exactly know why it is that the modern humans coming out of Africa were able to replace the Neanderthals. Okay, but they say in this study we show that the replacement could also have been the result of selectively neutral demographic processes. In other words, it's not that there was an adaptive advantage by the modern humans. Okay, it's just migration. They say our models suggest that recurring migration from Africa into the Levant and Europe, even at a low rate, was sufficient to result in the Neanderthals' replacement, even if neither species had a selective advantage over the other. Okay, so that's critical and foreshadows their results. Okay, so they say this replacement, the replacement of European Neanderthals by African humans, is found to have been extremely likely even if migration were bidirectional. So even if Europeans were going to Africa and Africans were going to Europe, the replacement was still inevitable. Why? Because there was just a much higher population in Africa than there was in Europe in this era of history. Okay, it's relevant to us today because there's not a lot of immigration going from Europe to Africa. It's overwhelmingly going the other way. So it's not really bidirectional. But even if it was, there's also a higher population in Africa, and the population of Africa is growing extremely rapidly, which is in contrast to Europe, whose population is shrinking due to low fertility rates. So briefly, if we go here, this is United Nations data on fertility rates by country. Basically, the darker the shade of the country, the higher the fertility rate. So this is in births per woman. So if you look at, for example, the country of Chad in Africa, there's 6.03 births per woman there, which is much higher than the fertility rate that you need to replace your population, which is 2.1 births per woman. So if a country is above 2.1 births per woman, it's growing, basically. If it's below 2.1 births per woman, it's shrinking in size. So if you look at every single European country, it's sub-replacement fertility, okay, which is disturbing. So these populations are shrinking, these populations are growing. So, when we're talking about the importance of population size and impacting replacement migration, even if you were to assume there's immigration going from Europe to Africa and from Africa to Europe, the fact that Africa is going to be having a much larger population size in the next century than Europe means it will be the Europeans who are replaced, not the Africans. Okay? And that's basically what they were saying here regarding Neanderthals. Okay, so now they get into their methods. So what they did is they say they basically do a computer model and a simulation. That's the study. So their model has two populations: moderns, which is basically the African humans, and Neanderthals, which is basically the European hominids. So you can consider this Africans and Europeans if you're going to try to apply it to today. Okay, they consider them, for simplicity, as two non-interbreeding populations. First of all, it's important to note that Neanderthals and modern humans did interbreed, but it doesn't really matter for this study. So we know from genetics that a lot of Europeans, they have Neanderthal DNA. Most humans in general have Neanderthal DNA. So there was clear interbreeding between the two populations in ancient times. Okay, but it doesn't really matter for the sake of the model. They say that they model them as two separate populations for simplicity, non-interbreeding, that initially occupy two separate demes, which basically just means two areas, Africa and Europe. They say they assume no selective differences between these populations, which basically by that they just mean assuming the same fertility rate between moderns and Neanderthals. So there's not an advantage that one has over the other. Okay, that's also an assumption that doesn't apply well to today because, as we just talked about, there's a much higher fertility rate in African countries than in European countries. Okay, so and the African immigrants that go to Europe, they maintain this higher fertility rate for multiple generations after they get there. Okay, so there is a selective advantage favoring the Africans today. Now, it's important to qualify that by selective advantage, we don't mean they're better adapted to European society. They don't do well. They don't do as well academically. They don't do as well professionally. They don't do as well economically. They don't do as well in terms of crime or anything like that. So they do worse in these societies, but they still have more kids. And the explanation for that is it's kind of obvious, but basically they're not family planning. They're just having kids. And then the country that they go to is basically taking care of them via welfare programs. Whereas the native Europeans, they're not having kids for many reasons. They're pursuing their career. They're pursuing higher education. They're trying to do family planning, but life is getting so expensive that they can't afford kids. So, and they're not willing to just be a welfare recipient for their lives because they have personal responsibility and they don't want to, be a public liability. Okay. So they're not better adapted, but there is a selective advantage today favoring African immigrants into Europe. Okay, so that's another thing that makes the conclusions of this paper even less extreme than reality. In reality, the replacement is going to happen much sooner and much quicker than this paper suggests. Okay, so again, they say we assume no selective differences between these populations and simulate a neutral drift process, which just means any changes are happening based on neutrality, random processes, not better adaptations by one or the other. Okay, and then the way that it works is basically in this analysis, there's various iterations of time. And at each time point, each time step, a cluster of individuals called a band randomly dies out. And this cluster of individuals can either belong to the moderns, aka the Africans, or the Neanderthals, aka the Europeans. So either a cluster of Europeans dies or a cluster of African dies, and they're replaced by a new band coming, again, randomly from either the Africans or the Europeans that are located in that area. Okay, now importantly, they couple this with migration. So in their first set of experiments, they basically say that bands from Africa can migrate into Europe at a low rate. And then later, in a second group of experiments, they consider bidirectional migration, where bands can go to Africa or bands can go to Europe. All right. And then it says each simulation is run until one species goes extinct. So now we're going to get into the results of this. So we'll start off with figure 1. Panel A at figure 1 is the only one we're going to focus on. But basically, this is talking about the number of time iterations, time steps, was required until the moderns. So that's basically the Africans successfully replaced the Europeans. And on the x-axis, this is basically Europe's population. So if Europe had a higher population, it basically took more time steps in order for them to be replaced. So that's kind of intuitive. If you're talking about waves of immigration replacing a population, well, the higher that population is in terms of its number, the more waves of immigration is required in order to replace them. Okay, panels B and C show something similar, but we can skip most of that. We're also going to skip figure 2. It's not that relevant to what we're talking about. So figure 3, this is showing 9 different runs of their experiment, their computer analysis. And the x-axis, this is basically time. And the y-axis is the proportion of the population, or rather the population size of Africans in Europe. So, for example, if we look at panel A, that shows that, there's low levels of Africans coming in to Europe. And then at this time point here, their population basically increases exponentially. And the orange circle represents the point where basically the native population has successfully been replaced by the incoming Africans. Okay, so it just goes to show you that inevitably, according to this model, the Africans replace the Europeans. Modern humans replacing Neanderthals. Okay, so for figure 4, now they're looking at if you have bidirectional immigration, what are the odds that the Africans, the modern humans, replace the Neanderthals? So the way that you interpret panel A, on the y-axis, again, that's the probability that the Africans successfully replace the Europeans. And 1 would mean 100% chance. 0 would mean there's a 0% chance. And along the x-axis, this is basically the ratio of the population sizes of those two groups, where N1 is the European population and N2 is the African population size. Okay, so if you have a low ratio, that means a much higher African population than European population, which is the situation we're about to find ourselves in the real world now. That gives you a low ratio, and you have a very high chance that the Africans successfully replace the Europeans. Okay, if the ratio is 1 over here, that means you have an equal number of Europeans as you do Africans. Well, in that case, it's a 50-50 chance that they get replaced because there's, essentially an equal number of Europeans going to Africa and an equal number of Africans going into Europe. And the populations that they're migrating into are the same as each other. So it's really a coin flip at that point. But if you have a higher African population, then even if there's two-directional immigration, which there really isn't in the present day, at least not significantly, then the Africans are all but guaranteed to replace the Europeans. Okay, we're going to skip panel B. We don't need to say too much about figure 5. They're basically looking to see how migration rate affects it. Basically, if there's more migration into Europe than there is from Europe to Africa, then the replacement happens faster. But that's pretty intuitive, so we don't need to go through this. This graph is more complicated than it's worth. Basically, the higher the migration rate into Europe, the faster the replacement. We're also going to skip figure 6. What they attempt to do here is account for basically the spatial location of these different groups as they interact with each other, but we're going to skip straight to the discussion where they talk about their major conclusions. All right, so if we get to the discussion, they basically say that replacement of Neanderthals was certain to occur, even for very low immigration rates, as long as migration was unidirectional. So what they meant by that is, if in their model all you have is Africans going to Europe and none of the reverse, replacement was guaranteed, even if the migration rates to Europe were very low. Okay, so again, that's applicable to the real world because migration out of Europe to Africa is very, very low compared to migration from Africa to Europe, which is extremely high. So it's practically unidirectional. Okay. It says, in other words, the scenario that our model proposes is not one of population swamping. In other words, it's not that there were hordes of humans coming into Europe and replacing the Neanderthals, but rather gradual replacement. So it was slower. Okay, today is probably different because the sheer volume of immigration is much higher than they're talking about in this model. They said, we've also demonstrated that even if bidirectional migration between Europe and Africa had occurred, moderns, that is Africans, would have been extremely likely to eventually replace the Neanderthals given estimated differences in population size between the two species in favor of moderns. So, in other words, if the African population is much higher than the European population, then even if there's migration going between the two, it is the Africans that will replace the Europeans and not the other way around. Again, that's applicable to us today because the African population is growing rapidly, whereas the European population is shrinking. Okay, so in a few years, in a few decades, we're going to see a massive population disparity between those two continents. Couple that with waves of immigration going from Africa to Europe and not the reverse, then we're basically in the exact situation that this model describes for Neanderthals being replaced by humans. Okay, so that's really all I wanted to talk about with this paper. This is just sort of a theoretical analysis that shows replacement migration from Africa into Europe. And it's very applicable to our situation today. Again, the situation today that we experience is actually worse because these authors, again, they assumed equal fertility among the two populations, but that's not true. There's much higher fertility rates among the Africans for various reasons that we mentioned. There's actually a lot of literature on replacement migration today, so we don't actually have to rely solely on speculation and analysis of prehistorical replacement migration events. So in future videos, I think we'll cover some studies that look at replacement migration today in Europe. Okay, it's a serious problem. It's probably the biggest threat that European civilization faces is mass immigration and low fertility rates. So we're going to talk more about it in future videos, but thank you for listening.